In today's class, we will be diving into chapter 7 coordinate geometry of class 10. We will be focusing on the distance formula. And distance formula is the foundation of this entire chapter, chapter 7. This formula basically allows us to calculate the distance between any 2 points on a Cartesian plane. So suppose we have 2 points A and B with coordinates x1, y1 and x2, y2. So we join AB. So this is the distance and we have to find the distance AB. So we have coordinates of A as x1, y1 and that of B as x2, y2. So we need the Cartesian plane and the frame of reference, because in coordinate geometry the calculations are always done on the Cartesian plane and we should have a frame of reference. So suppose this is the frame of reference. X-axis two mutually perpendicular axes, x and y. This is the x-axis, this is the y-axis, this is the Cartesian plane, and these 2 points are located on the Cartesian plane with coordinates x1, y1 and x2 and y2. Now we need to find the distance between A and B. So how is that calculated? If we draw a perpendicular from point A to the y-axis, the perpendicular distance that represents the value of x1, which is also known as abscissa. And if we draw a perpendicular from A on the y-axis, this distance is the value of y1 or the ordinate. Okay, perpendicular distance from y-axis gives us x1 and perpendicular distance from x-axis gives us y1. Similarly, perpendicular distance from B, perpendicular distance of B from x, that gives us y2, and perpendicular distance of B from y-axis gives us x2. Suppose this is the point O, the origin. Let us name it B, E, F, P. Okay. Now let us extend this line and this one meets this line at C. Okay. Since this is a perpendicular line, on this line, this is also these two are mutually perpendicular. This line and this line, right? So this is a right angle triangle. SEB is a right angle triangle. Okay. Now, on a right angle triangle, we apply the Pythagoras theorem. Right? AB square is AC square plus BC square. What is AB square? It is the hypotenuse. This line, hypotenuse of this right angle triangle. Hypotenuse square is AC square plus BC square. AC square is base square. This is the base of this right angle triangle. And this is the altitude of this right angle triangle. So hypotenuse square is equal to base square plus altitude square. Right? So AB is square root of AC square plus BC square. Okay. Now what is AC? This distance AC, right? This is equal to this distance minus this distance. This distance AC is equal to this distance FB minus this distance PA, right? And what is FB? It is x2. What is PA? It is x1, right? Then BC. What is BC? BC is equal to BE minus CE. BE minus CE. What is BE? BE is Y2. What is CE? CE is equal to AB, which is equal to Y1. So we have AC is equal to x2 minus x1 and BC is equal to y2 minus y1. So this whole thing becomes x2 minus x1 whole square, y2 minus y1 whole square, and that is your distance formula. Distance between any two points can be obtained like this if you know the coordinates of the 2 points. Okay. Here one more important thing. This formula can be written as x1 minus x2 whole square plus y1 minus y2 whole square also, because the order does not matter here. You can write x1 here or x2 here like this, because if you square it, it will become positive. So it does not matter whether you write x1 or x2 before. Similar is the case with this coordinate also. You can write y1 or y2 first. So this is the formula for finding distance between any two points on the Cartesian plane. Okay. So for example, if we have 2 points like this, what will be the distance between the 2 points? Let D denote the distance, then it will be equal to, let us apply this formula, 3 minus 7 whole square, 2 minus 5 whole square. This is equal to 4, 4 square is 16, 2 minus 5 minus 3, it is 9. Square root of 25, it is 5. Hence, distance will be is 5 units. Right? So this way we find the distance between any two points. Now, as you know, coordinate values of the coordinates, they are positive on the first quadrant. X coordinate is positive and y coordinate is also positive, but x coordinate is negative and y coordinate is positive on the second quadrant. So what you will do in that case? How you can apply the distance formula? Or can you apply the distance formula at all? Yes, of course. Distance formula is applicable anywhere. First, second, third, fourth, it does not matter. Okay? The values of the coordinates can be positive or negative. It does not matter. For example, you can have points like this. Suppose a point is like this, minus 4, 3, then 2 and minus 7. Like this. It does not matter. You can apply the distance formula in this case also. You just have to apply the distance formula. Take this one as x1, this one as y1, then x2 and y2, first point, second point, then apply this formula. Minus 4 minus 2 whole square plus 3 minus minus is plus 7 whole square, then 6, 36, 10, 100, 136, like this. Okay, you just have to find out the values of the coordinates and then apply the distance formula like this. You will get the distance between the 2 points. And one more thing, the distance from the origin to any point, suppose between this point and this point, this is the point x1, y1, and this is the origin where it is denoted by 0, 0. Origin is 0, 0. So the distance is x1 minus 0 whole square, y1 minus 0 whole square, right? Because these are 0, 0, we have it is equal to x1 whole square, y1 square. So you see, to find the distance between the origin and any point is just squaring the x coordinate and add it with the y coordinate like this, squaring the y coordinate, then taking the square root. That gives us the distance between the point and the origin. So that's it for today. In the next class, we will do some numerical applications based on this distance formula, and we will also do the section formula and some other concepts.